So this is the lesson on page 6 of the unit handout. We're talking here about example number 1. You're trying to find the value of x that makes these three things arithmetic from one to the next to the next. And a trial and error approach is not going to work. But the key in solving this problem is to recognize that if I take the second term minus the first term, if I do that, and I take the third term minus the second term, I have to get the same thing. Because the second term minus the first term will give me what we call the common difference, and the third term minus the second term will give me the common difference. So let's do that. The second term is 17, and I'm going to subtract away from the second term the first term. Equals, I'm going to take the third term and subtract the second term. So a couple of things. First things first. I've intentionally put a mistake in there. And it's by far perhaps the most common mistake that high school math students make in solving a problem. Unfortunately, it's a junior high mistake. And that's bad because it's something that if you make, you may understand the math 20-1 or 30-1 quite well, but if you make a mistake using some basic algebra, you're going to get something wrong, obviously. Does anybody know what the mistake is? It's a brutal one. It's one that you do not want to make. Sukman?
Negative 2 should be 3x, negative 2.
Pardon me?
It should be 17, negative 3x, and negative 2.
Okay, so I'm going to paraphrase that or explain it to other people. We need to subtract 3x plus 2. That's what you're saying, right? We need to subtract the entire first term, not just the 3x and the 2. So there are a number of ways that you're taught in junior high how to handle that. Some of you may prefer to say, well, I really have a negative 1 here, so I'm going to multiply that negative 1 through and get 17, and then negative 3x and negative 2. I prefer, and maybe this is what you were just thinking in your head, to just say, well, I'm subtracting 3x plus 2. So I'm subtracting 3x and I'm subtracting 2. I would still write it in brackets before I wrote that. Okay? Whenever you're subtracting something, make sure the thing you are subtracting is in brackets. So for example, we should really put brackets around the 17. It doesn't matter because 17 is a monomial, right? We're just subtracting 17. It's not that big of a deal that there are brackets there. But if you get in the habit of putting brackets every place subtraction occurs, then you won't miss putting it someplace where it does need to be. So we have 17 minus the 3x minus 2 is equal to 10x minus 7 minus 17. So let's simplify things. Simplification in this context means writing things in an easier method or easier form. I mean, we don't walk around saying, oh, it's 17 minus 2. If the sales price, if the regular price is $17 and you're saving $2, you don't go to the cashier and the cashier says, okay, you owe me 17 minus 2. The cashier will simplify that and say you owe me 15. So this is 15 minus 3x is equal to 10x minus 24. We're bringing all of the common terms together. And now it's a basic linear equation. It has x's and it has numbers. So you're going to move all of the x's to one side and all of the numbers to the other side. And we were talking a little bit at the end of yesterday's class about, do I need to, if I'm moving the 3 over, do I need to write minus 3? And I answered no. So I'm going to write something down and then erase it because it just gets too cluttery. You know, the thinking here is this is what we're doing. you're adding 24 to both sides to clear the numbers away from the right-hand side, and you're adding 3x to both sides to move all of the x's to the other side. I think what I've done is I've created confusion here. I really believe that. When you look at it, it's a nightmare. It's a mess. Why don't I just say, well, I'm going to move the x's to this side and get 13x, because 10x plus 3x is 13x. I'm going to move the constant terms to the other side, so I'm going to take 15 and add my 24, which is 39, and I get x is equal to 39 divided by 3, which I'm sure you will vouch for me and say that, 39 divided by 13, and you'll say that that's equal to 3, right? All right, well, let's take a look at the original sequence. The original sequence was 3x plus 2, comma, 17, comma, 10x minus 7. I want to make sure I've written that down correctly. Yep. So what happens when I take x equals 3, which is the solution to the question, and I put that 3 here and here? What do I get? What's the first number I get? I get 3 times 3 plus 2. Then I have 17. And here I get 10 times 3 minus 7. So 3 times 3 plus 2 is 11. 3 times 3 is 9, plus 2 is 11. Then I have 17. If I'm on the right track, then the common difference is 6. I can see the common difference is 6, 11 to 17. So I'd better get 23 here. And if I take 3 times 10, I get 30, minus 7 is 23. It works. Now, could you have stumbled on the magical number being x equals 3 by trial and error? Sure, but what if the number was negative 10 or 26? It would be almost impossible for you to just, by trial and error, come across it. So, have we answered the question? The question is, determine the value of x. We found x is 3. What is the value of the first 3 terms? The value of the first 3 terms, values are 11, 17, and 23. The common difference is 6. Keep in mind, and we're just starting out early. I mean, things are going to escalate in terms of difficulty. But keep in mind, I could have given you this information, and instead of asking you, what's the value of x, what's the common difference, what's the first 3 terms, I could have just said, okay, what's the 8th term? And if I say, what's the 8th term, your brain should say, well, I better know the first term and the common difference, so I'd better use this method to find x, so I will know the first term and the common difference. All right, let's move on. Number 2. The third term of an arithmetic sequence is 30, and the 10th term is 114. What are the parameters that define this sequence? And we're asked to solve this in a very specific way, using a system of equations. And I'll come back to that in a bit. So all I'm going to do is take this general formula and I'm going to put in 2 sets of variables. I have this statement. I want you to mentally digest why, based on the question, I'm saying n equals 3 and t sub n equals 30. It's saying because the third term is 30, that's why. If the third term is 30, when n is 3, tn is 30. Okay? On the other hand, that's true, because the 10th term has a value of 114. Would you agree, and there's a simpler way to do this, but you have to have faith in me that I'm showing this to you for a reason. because the simpler way to do this is not something that will always work for all math problems, but this way will work for a lot of math problems. Would you agree we have two missing parameters? Right? The missing parameters are the first term and the common difference. And when I went over today's homework, I think it was number 9, I went over it and I said, when you have a missing parameter, that phrase, missing parameter, tells you you need to load in a pair of variables. Right? Something you're going to see again and again and again. Well, I'm going to load into this general equation at the top here a pair of variables. And I am going to get T sub n is 30 equals T1 plus, man, you guys, I so just want to write 2D here. I really just want to write 2D because it's 3 minus 1 times D. But I will do that. Okay. And now let's write 30 equals T1 plus 2D. So this is kind of a strange question, and this goes back to the final unit in Math 10C. Why can I not use this equation that I've written? Why can I not solve that for T1? Right, I don't know D. And I could turn it around and say, why can't I find D with that? Because I don't know T1. And what you learn in Math 10C is that if you have an equation with two unknowns, you can find those if you have a second equation with two unknowns, with the same two unknowns. And I can arrive at that equation by using this second pair of variables. So when I use this pair of variables, I get that equation relating the parameters. When I use this, what happens? I get 114 equals T1 plus, and again, everybody, I would just like to write 9D, but it's 10 minus 1 times D. So I get 114 equals T1 plus 9D. Here's my second equation. And now I have what these two things are a system of equations. And I use my, what I would describe at this level is this way. I use my mathematical prowess to find the unknowns. I use algebra that I've picked up along the years, and I maybe do something, I would probably do this. I would probably subtract the equations. This is what you call in Math 10C the method of elimination, where you add or subtract equations. And the reason why subtracting these equations bears fruit is because they each have one T1 in them. So when I subtract T1 minus T1, I don't have to worry about it in my calculation. So 114 minus 30, help a guy out here. I'm pretty sure it's 84, but sometimes on Friday my brain shuts down a little early. And then 9D minus 2D is 7D. So now I can find out what D is. I'd like to say 12. Is that right? 12. So 84 divided by 7 is 12. I now know the common difference. So how do I, and this is not, everybody, the answer to this question does not lie in, oh yeah, how did we do this again? It's not a memory thing. It's look at the math skills and look at what's on the screen. What can I do now to find T1? Georgia? Put 12 in for D. Where? Into any equation that connects T1 and D. I would be maybe inclined to use this equation only because the numbers are smaller than the other equation, but it's not going to matter. So now I put in 12 for D. I get 30 equals T1 plus 2 times 12. So T1 plus 24 is 30. Now I know T1 is 30 minus 24, which is 6. You could certainly check this now, and you don't need to write this. I'm just going to write it quickly. You could certainly check it by taking your general formula, putting in 6 for T1, putting in 12 for D, and then going back to the question and seeing that it was the third term that was 30, putting 3 in for N and see if you get 30. And put, I think the 10th term was 114, put 10 in for N and see if you get 114. All right, next question. This one is a little bit easier. This question, and I think maybe the next one, are simply trying to tie the concept of arithmetic sequences to some application. So an HVAC technician, somebody who works with plumbing and heating and air conditioning, makes house calls and she bills her clients according to this schedule. So she's running her own private business. The bottom line is if it's 1 hour at the client's house, it's $115. If it's 2 hours, it's $155. If it's 3, it's $195. Are you with me on that? Maybe with a little bit of just thinking, you can see that every additional hour she charges $40 more. But she doesn't charge $40 for the first hour. She charges more. Okay? Write a general term for the billing amount if the number of hours correspond to the term number. And it says in the question, this is an arithmetic sequence. So what we're saying is that this is N, and this is Tn. In other words, T4 is what she would charge if it were 4 hours of work. T2 is what she would charge if it's 2 hours of work. Well, that means the sequence is this. And this is a problem you could have solved yesterday. Right? It's asking you to find a general term. Well, this is your formula. Whoops. So we put in, what did we say here? The first term, well, look at the list of numbers. The first term is 115. The common difference is 40. Put those numbers in. So Tn equals 115 plus n minus 1 times 40. And since we're asked to find the general term, we ought to simplify this. Multiply it out, bring it all together. Tie it down into a nice little package. If all you were going to do was use this to find out what Tn is when n is 6, then you could just put 6 in. But if you're asked for the general term, you want to simplify it. Everybody just take a gander at that line that I wrote and make sure you understand where I'm getting 40n minus 40 from. Pretty basic. I'm multiplying that 40 through up here. And then I can take 115 minus 40 and get 75 plus 40n, which is the same as 40n plus 75. My subtraction's right, isn't it? 75? Okay, good. Thank you. Do you have a B for this question? Why am I missing that page? Oh, it is there. That's weird. What would a customer call of 6 hours be billed as? Well, we have this formula, right? T sub n equals 75 plus 40n. Is my memory okay on that? That's what we said? Okay. So I put data tables in here for you to appreciate something. That what is going to happen in B is that we are going to put this in for n and find the other thing. Whereas what is going to happen in C is that we are going to put this in for Tn and find the other thing. And I hope you would agree that solving B is simpler than solving C. Because there's no rearranging, right? You're just going to go 75 plus 40 times 6. $315. Whereas over here, you're going to put in oh, really?
It says 95, like $395.
It says what?
395.
For C?
Yeah.
Okay. That's good, because otherwise we wouldn't really think too much about what would be the answer for C. 395. Whoop. So we put 395 in here. Again, everybody, this is child's play at this point. A two-step linear equation to solve: subtract 75 from both sides, divide both sides by 40. I'm guessing it's 80 or 8. It's 8. N is equal to 8. And that's it. We really should put dollars here, I guess, and 8 hours here. All right, we have one more question to do. This one is a word problem as well. It's a little more, it requires a little more thought. Jonathan has a part-time job at a local grocery store. He's asked to create a display of cereal boxes, and the number of boxes in the rows produce an arithmetic sequence. So you can visualize what's happening here. There's a row of boxes on the floor, and then above it, there's a row of boxes where there's fewer boxes and fewer and fewer and fewer. And it's arithmetic. It says there are 16 boxes in the third row from the bottom. So if we look at this logically, it makes sense for us to say when n is 3, Tn is 16. But you need to be aware that as soon as we do that, we're committing ourselves to the fact that we're saying the bottom row is T1. The bottom row is T1. It has to be. And there are 6 boxes in the 8th row from the bottom, so when n is 8, the 8th row is the 8th term. The number of boxes is 6. Can everyone appreciate that the common difference must be negative? Right? Okay. So, take a look at this question. Okay, just take a look at the information you have in this question. I'll freeze it on the right-hand screen. And take a look at the question where I gave you this information and asked you to solve for the first term and the common difference using a system of equations. I hope you see that these are the same type of question. But I hope you remember, I said there's a much simpler way to solve this problem. Okay? And once again, I would like you to understand, I showed you the more complicated way because you need to know how to do this for other things that the simpler way wouldn't work for. Okay? And it's a nice place to review it. So what's the simpler way to find those terms? Well, I'm going to write down a statement, and then I'm going to ask you if it makes sense. You're really going to have to think. See, here's my thinking. And now I'll show this visually with blanks. This is the bottom row, the first term. Second term, third term has 16 boxes. Fourth term, fifth term, sixth term, seventh term, eighth term has 6 boxes. So what do I add to this term here to get to this term? Well, I add 1, 2, 3, 4, 5 common differences. Incidentally, if I go back to that other problem where we use the system of equations, how many common differences would you add to the third term to get the 10th? 7, right? The difference between them is 7 common differences. So we could have just started off by saying that. Let's subtract the 2 terms and set it equal to 7d. However, I think this is the best way to solve this problem. To basically say, everybody, the third term plus 5 common differences would give you the 8th term. Why am I adding 5 common differences? Because to go from the third to the 8th is 5 leaps, 5 hops, 5 transitions. So I can put 16 here. And I can find the common difference. So I subtract 16 from both sides and I get 5d equals negative 10. I divide both sides by 5 and get d equals negative 2. So the common difference is negative 2. Sometimes you don't have to make things complicated. We can find the bottom row here by just working backwards at this point. You don't need a formula or anything complicated. If the common difference is negative 2, that means there must be 18 boxes in this row and 20 boxes in this row, which is the first row. So the answer to part A is there are 20 boxes in the bottom row.